In the last session, we saw about measure of central tendency. This session, we will see measure of dispersion. Under measure of dispersion, we have mean absolute deviation, and standard deviation. Of these two, standard deviation is a very reliable measure of dispersion. We will see by way of the examples. We also learned one more important measuring parameter called coefficient of variation. Coefficient of variation is a relation between the mean and standard deviation, and it is an expression on the variation of the data. So it's a ratio of standard deviation to mean, which will express certain numbers, and that will be an indicator of the variation. Conversely, it can also be said the coefficient of variation is a measure of consistency also. Lower the coefficient of variation, higher the consistency. With this, we will go into the presentation and understand more about it. Let us take the example of sprinter's record, which we considered in the last session. This table provides you his trials at the speed and the mean value of 12, and the deviation in every trial with respect to the mean is shown by x minus x bar. So which is 11 minus 12 is minus 1, and second trial 11 minus 12 minus 1, 15 minus 12 3, so on and so forth. Now x minus x bar is the deviation. The modulus of the deviation, which is without the sign, you get the same with all positive values, and they adds up to 9, and if you divide by the total number of trials, you will get mean absolute deviation, which is 1.3. So this is the way you calculate mean absolute deviation, and you understand by this process, yes, there is a deviation as far as his records are concerned, or as far as trials are concerned. Now let us understand yet another measure, that is standard deviation, which is regarded as fairly a very good deviation measure. In this, what we do is the same x minus x bar, which is the deviation, but they are taken as the variance, that is the square of that, and you can see that it is 11 minus 12 minus 1 square is 1. Like that, when you do this, you get 1, 1, 9, 4, 4, 1 and 0, and the total of the variance or the deviation square is 19, and the standard deviation is given by the formula under the root sum of variance x minus x bar the whole square by n, and that is why we call this as root mean square deviation, because the variance we have divided by the total number of trials and taken the root. So in these examples, rather in this example, we got two measures of dispersion, mean absolute deviation and standard deviation, and their respective values are 1.3 and 1.6. By this, what we understand is that considering one standard deviation, the sprinter will clock between 10.4 seconds to 13.6 seconds in his attempts. That is 12 minus 1.6 is 10.4, and 12 plus 1.6 is 13.6. Let us take another example. A cricket team manager wants to strengthen his team's batting lineup with one more good and reliable batsman. For him, a consistent batsman would be fine and not a high run getter, as he is confident of training an average batsman to perform better. He visits a sports college looking for batsmen. He was recommended by the principal two players A and B, and their average are 51 and 56 respectively. Although he was tempted to pick the player B, he decided to have a look at the scorecards in the last or recent 10 matches. After looking at the records, he has changed his mind and picked up player A. Let us see how and why. These are all the 10 records or 10 innings records of player A and player B. By calculating the mean and standard deviation, we get 51, 56 as mean respectively, and standard deviation 7 and 36 respectively. One standard deviation would mean the player A will score between 44 to 58 runs and player B will score between 20 to 92 runs. So what can happen is that with one standard deviation, definitely the player A is likely to get anywhere between 44 and 58. On the contrary, player B may be 20 or maybe 92 or anywhere in between. So considering these things, definitely player A is more consistent than B. Now let us explore coefficient of variation. Coefficient of variation is a very important measure. They help us in understanding the variations in the data or the variability of the data. The coefficient of variation is the ratio of standard deviation to the mean. Normally the data, the mean is represented by mu and the standard deviation is represented by sigma. So you can see clearly this is what is the ratio or the coefficient of variation is expressed as a percentage of standard deviation over mean into 100. We will understand coefficient of variation by way of some examples. In the last example, the player A we found to be more consistent looking from the standard deviation point of view. Now the same thing is worked out here, and you will find that coefficient of variation of player A is 13% and coefficient of player B is 64%. This only tells that smaller and smaller the coefficient of variation, higher is the consistency of data. The coefficient of variation is a very valuable parameter which tells about how varying is the data or how consistent is the data. Consider this scenario. In the stock market, one stock has a market rate with a mean of 100 and a standard deviation of 4, and another has a mean of 10 and a standard deviation of 3. Looking at the data, looking at these two values, mean and standard deviation, the former seems to be riskier because the standard deviation is more. And the variability with one standard deviation is 96 rupees to 104. On the contrary, the latter has more significant variation, although the standard deviation is less. See, it will vary from 7 to 13 with a mean of 10. You can see one should not only look at standard deviation, you should also consider the mean. Rather, the mean and standard deviation have to be considered together to have a better understanding of the data. So in this case, you can also see that if you work it out, the CV in this case are 2.5% and 30%. See the large difference. With this, we have come to the end of the session. We have so far learnt a measure of central tendency and a measure of dispersion. Under measure of central tendency, we learnt mean, mode, median, and under measure of dispersion, we have learnt mean absolute deviation, standard deviation. A very important measure, which is a measure of consistency, or you can also call it as a measure of variation. That is coefficient of variation. And it's a very, very important parameter because that tells a very good idea about the entire data. We will take into new chapters in the next session. Till then, bye.